Hello viewers, welcome back to my channel. In today's video, we will learn how to derive the worst observation carry forward, which is also known as WOCF. As we know that this is the worst observation carry forward, but how we know that which observation we have to take as the worst? That is, for a particular test, either the maximum value will be taken as the worst or the minimum value will be taken as the worst. So how we judge about this? For example, some tests like hemoglobin, these tests treat the lower value as worse, whereas tests like ALT or blood pressure treat higher values for worse. So WCF is an imputation method where we replace missing post-baseline values with the worst value observed so far. It is often defined in the SAP to which, depending on the test or the param CD which we have in our data, that whether we have to consider the maximum value or the minimum values from the values available as the worst values. This help ensures the efficacy or safety analysis. Again, another challenge we will face while deriving the WOCF is that in a particular data set, in the real time, we will have different tests and each has its own rule for what is worst. For example, for hemoglobin, we know this will have as the minimum value as the worst, whereas the ALT will have the maximum as the worst value. So how we can derive the worst observation carry forward for both in the same data set. So now let's see how we can achieve this in if we have such type of scenarios in a single data set in our real time. Right now, I'm showing you one of the dummy data set where I have created these two tests, that is the hemoglobin as well as the ALT for a single subject for 3 different visits. And you can see that for the hemoglobin, which is also known as the HGB, I have the missing value of AVAL for week 4, and same is the case for ALT. But now the question arises is that since in this particular data set, which we will also find in our real-time scenarios while working in any clinical trial, that the lab data specifically will have the data from many tests, and we will have different scenarios to which to consider the worst values as the minimum value or the maximum values for that particular test. So in line with that example, I have created this data set, and now I want to derive the WCF for my week 4 for both of these tests, and we will see how we can achieve that. So for this, we will normally use a reference table to define which direction is worst for each param CD. That is, if in this scenario, if my HGB is going to take as the minimum value as worst, then I will have mark this param CD with a another variable that it will can contains the values of minimum, and the for the ALT I will have a variable which will contain the value of maximum, so that I can use that column variable in my programming logic to know that which param CDs are defined to consider the minimum values for worst or which to consider for the maximum values as worst. So now let's see how we can write the SAS code for this. So as I have told that I will be using the reference table to define the direction in which the worst is being considered. I have created a dummy intermediate data set here by the name of test underscore worst underscore dir, where I am keeping the param CD and the another variable in which I'm mentioning whether it will have to take the minimum value or the maximum value as the worst value. Right now, I have given the param CDs from my own, since these are two values, but you can also derive the list of distinct param CDs from your LB data or this data set on which you are working by selecting the distinct values of param CDs in the proc SQL step, or using a no dupe, sorting the data set, keeping the param CDs and using the no dupe key to get only the param CDs values, and use that particular data set to create another variable and have the values defined in this way. So if I run this data step, I will have created a dummy data set here, which will have the values of my param series and the direction or the values which I have to consider for the worst. So here you can see that for SCB, I have to consider the minimum values as worst, and for ALT, I have to consider the maximum value as worst. So moving on to the next step, what we can do is we have to first merge this data set, the intermediate data set which we have created, with our lab data which I have shown you, which is my ADLB underscore raw. Why? Because I want to get that particular variable uh, in my ADLB raw also. So I will merge these two data sets by the param series to get the desired column in the resultant data set. So here I'm using the proc SQL function or procedure, you can see, where I'm creating another table by the name of ADLB underscore merge, and I'm keeping all the variables from my lab raw data set, but only keeping the newly created variable, which is the worst underscore dir variable, having the information of which variable, which param city will have the minimum value or the maximum value to be considered as the worst, and then joining based on the param city here. So if I run this, you will see that my worst underscore dir column is also created, and based on the param CDs which we have in our data, the respective worst underscore dir column is populated. Now, since now we want to consider the worst value, the first step is that we sort the resultant data set in the correct uh, sorting order. And since we have to sort it by the chronological order, because we want that the first baseline should come as the first observation, and then based on the visit we want the values. In that way, we are using the param cd and ADT variable as the sorting variables in this case to sort the data set, that is the ADLB underscore merge, which we have just created. So now we have sorted it based on our param cd and the ADT values, and you can see that the baseline values is coming as the first observation. Week 2 and week 4 are coming as the second and third for both of the subjects. Now we apply the logic on how to derive the worst observation carry forward. So we will use the sorted ADLB merge dataset here, and we will use the same sorting variable to use the first dot functionality. So because of that, we are again using the by statement after the set statement here, and we are using the by variables as the use subject ID and the param cd. The next is that since we want to retain, or you can say we want to judge which record value will be the worst value. So we are creating a intermediate variable, which is the worst value variable, and we are going to use the retain function of this because we want to know that what was the previous value for this in this particular variable while we are checking for the values along with the a-val. So we are creating a variable, we are defining a variable worst underscore val, and we are retaining that variable. So now the first step is that if the param city is the first occurrence of the param city, then this variable will be marked as missing, because we do not want that for the second or for the all like when it will go to the second param city, we do not want the previous values in your worst underscore val variable to overwrite for the next param cd. So because of that, we are using the first dot functionality here that reset the worst underscore val variable value to missing for each newly first occurrence of your new param series. So now the next step is to check and get the values, which is the worst value for the said param cd. Now, since as we have defined that the WCF is defined only for the post baseline records, because of that, I have put a filter that for the records which are the baseline record in this data, as I've shown you earlier, that for baseline my a visit is 0. I have applied a condition that my a visit n should be greater than 0. That is the records which are post baseline records only I'm considering, and if the a value is not missing, in that scenario, what we will do is we will set the worst underscore a val value to the a val value, and for the first occurrence, and for the next one, if the worst underscore dir is minimum and the a val is less than worst value, because here we have to see, we have to get the minimum value for a for that particular test. That's the reason that we are checking that the value which we have retained in our worst underscore val, is that value uh, less than the current record value. If that is the case, then the worst underscore value will be reset again to the current record's eval value. Same is the case that when worst underscore dir is max defined as maximum, that means that the set param cd will take the maximum values as the worst value. And in that scenario, if the worst underscore val value, which is being retained from our previous record, we will compare that particular value with our current eval value. And if in that scenario, the eval is greater than the eval of our previous record, then we have to reset the worst underscore val value to our current eval value, because the value which is currently present in our worst underscore val variable is not the maximum value for this scenario. So using these three lines of code, you can define or you can identify which is for depending upon the test, which whether the test is taking the maximum value or the minimum value as the worst, we can define which is the worst value for a particular test in this line of code. Now, having done that, what the last step which we need is that for the scenario where the eval is missing, we will have to set the eval value equals to the worst underscore val value. And we are again creating here a d type variable, and we will mark the t type variable as the uh, WCOCF, because we want to keep a record that this record is having the eval value being derived as the worst observation carry forward. So using this last statement, section of the if clause, we are just assigning the missing eval values with the worst eval values which we have calculated in the above mentioned if section. So using this data step, you can achieve to create a WOCF records for the scenarios where the eval is missing in the dataset. So let's run and see the resultant outcome. So here you can see that our D type value is populated as WOCF for the records which were earlier having the values of eval as missing. If you remember, the week 4 for both of the tests was having the value of eval as missing. Let's go and check that. You can see here that HGB as well as ALT was having a missing value of eval for visit 4. Now, after applying the WSF logic, we can see that the eval value for week 4 for ALT is being populated by the maximum values of the available records. So if you see, since ALT was the param CD which will take the maximum of the available result values, we can see that out of 30 and 55, we are using the maximum value, which is the 55 value in week 4. Same is the case for HGB, in which we know that the HGB was defined to take the minimum value. So out of the available values, that was 13.2 and 12, what was the minimum value of of this was 12 and the same is being kept populated in your week 4. So in this way, you can achieve your derivation of WOCF here. That's all for today. Thanks for watching. Don't forget to like, share, and subscribe for more SAS programming tutorials.